All right. Did you get one of these? Okay, good. All right. Okay, so this section is on linear equations, and I realize most of you have seen this before. If there is something, I'm going to go pretty quickly through this, okay? Because I mean, we've got other things that we could spend, more time on. If there's something on here that doesn't make sense, or you need a slower explanation, please come talk to me. I had one person talk to me yesterday that said, hey, I should have sent you an email and I haven't. Looking over your test corrections, some of you should definitely send me an email and say, I don't know how to factor very well, or I don't know how to work with rational expressions or negative exponents. So if that's you, please send me an email, tell me what you know you don't know how to do, and we'll at least start there, because those things are not going to go away, okay? All right, so one of the easiest things that we can graph is a line, so we're going to talk about a linear equation, okay? And again, I think we mentioned this yesterday. We call it a linear equation because, oops, let me just write line here if I can get that out. Not wanting to cooperate there. Okay, so we call it a linear equation because when we graph it, it makes the shape of a line. And you're probably familiar with this form of a linear equation. This is called what? Slope-intercept form. Now, this would actually be better if we added a little letter right here and we called this slope Y-intercept form. Okay? Now, we know that right there is the slope and that is the Y-intercept. But if you just say intercept, okay, could be the X or the Y, okay, and it drives home the point that in order to make this equation, you have to know two things. You have to know the slope and you have to know what the Y-intercept is. You have to know right where it crosses the Y-axis, okay? This is a form of a linear equation that we teach all the time in the United States. This isn't as heavily emphasized if you were to go to another country, okay? And we'll talk about why that is. So let's again make this point. You need two things to write the equation of a line. You need at least one point, and you need the slope. No matter what the form of the linear equation is, you have to have those two things, a point and a slope. Now, sometimes they give you the slope, sometimes they kind of hide what the slope is. So they've got to give you the slope or enough information that you can figure out what the slope is, okay? So let's make sure we're clear on this. I think this is the healthiest way to think of what slope is, okay? Notice that I've got this in bold. Slope is a fraction. Slope is always a fraction. In fact, when you get into calculus, we call slopes rates, and we're going to do that a little bit in this class right here, okay? A rate is a ratio of two numbers. It is a fraction, okay? So we're always going to want to think of it as a slope is a fraction, okay? One number over another number, okay? And what it represents is how steep the line is, and it represents one other thing, the direction it slants. So I've got four examples of lines right here. Okay, this one goes up from left to right. This one is perfectly flat or horizontal, and this one goes down from left to right. Okay, this one we usually represent as a positive slope. This one we represent as a negative slope. And what is the slope of this one right here? Okay, glad we're talking about this. The correct way to talk about this is 0. It is not undefined. It is not no slope. It is 0 for a slope, okay? There is a number that represents how steep it is. There's a number that represents how steep this is. So the way I like to think of this, or have people understand what slope is and the difference between 0 slope and no slope, most of you probably ski or snowboard or something like that. Let's say you hopped in a helicopter and they were going to take you up in the back country and have you go snowboarding or skiing or something like that. Let's say they dropped you on this slope right here. You jumped out of the helicopter, just maybe 4 or 5 feet, fluffy snow and stuff like that. Is there something for you to land on? Yes. If there's something for you to land on, there is a number that represents how steep it is. Okay? So there's something for us to land on here. There's a number that represents that, and we use positive numbers to represent slopes like this. On this one right here, if you jumped out, is there something for you to land on? Yes, so there's a number that represents how steep that is. Okay, we happen to call those negative. Now, if you jumped out on this one right here, is there something for you to land on? Yes, So there's a number that represents how steep that is, and we happen to call perfectly flat, right in between positives and negatives, we call that 0. So each one of these has a number that represents how steep it is. Let's slide over here. If you jumped out of a helicopter and tried to land on that slope, is there anything for you to land on? There is not. So there is no number that represents how steep that is. So this is no slope. Or we can say that the slope is undefined, is what we could say. All right? Positive slopes, negative slopes, 0. All have numbers that represent how steep they are. There is no number that represents how steep a vertical line is. Okay? Any questions? Okay, so there are two general ways or two usual, typical ways of talking about slope. One way is we can say it's the rise over the run. Very good graphical description of what the slope is. The rise is the change, whether we go up or down. The run is whether we go right or left and how far. We can also represent that with a formula. What's the formula that would do that for us? Figure out the change up and down versus the change right and left. Hop? You know what it is? Good question. This is what people always mess up. They know what the formula is. It's that x2 minus x1, y2 minus y1, but they can't remember which one goes on the top and which one goes on the bottom. So let's think. Everybody knows rise over run. Rise. Which variable goes up and down? The y does. Okay? So this is y2 minus y1 over x2 minus x1. And you've got some very simple equations here, very simple problems. Some of them just say, find the slope of the line that goes through these 2 points. So again, we're going to call this one x1, y1, and this one x2, y2. And if people make mistakes, this is the mistake they make. You with me? y2 is negative 2 minus 3. x2 is 6 minus, oh, there's already a minus there. I don't need to write that. Okay. You do. Please do yourself a favor and do this. On this one, write down the 6. The minus is part of the formula. Before you even go look at what x1 is, write the minus. x1 is negative 4. Both of those have to be there because this is going to be negative 5 on the top and it's going to be plus. So this is going to be 10 on the bottom. Always simplify the fraction. So this is going to be negative 1/2. Now that tells us something. That tells us that the slope is negative. It's going to go down from left to right. And the run is bigger than the rise. Not a very big rise. Run is 2. So if I graph these points, and graphing is not a very good way to figure out what it is because you've got to draw an accurate graph. So let's do negative 4, 3, and 6, negative 2 would look like this. Okay, those are the 2 points. I suppose if you wanted to go through and count, here's the rise and here's the run. Well, guess what? You get negative 5 and you get 10. You can do it that way, but graphing them and counting squares is generally a horrible idea. You have some problems on the assignment that have fractions or decimals in them. That's really hard to do by graphing. Okay? So much better to rely on this formula right here. Again, notice that it slopes downward and it's not all that steep. Okay? That would be a pretty darn steep ski hill though, if you think about it. Any questions? Okay. You have some problems that say name the slope and the y-intercept and then graph. The nice thing about these is they're in that nice graph-friendly form, slope y-intercept form. So we know that it crosses at 2. So B is 2 in this particular case. We know the slope is negative 1. So it crosses the y-axis right here. And we know that this is a slope, so this is a fraction. So this means the rise is negative 1, the run is 1. So down 1, right 1. Down 1, right 1. We just continue that exactly the same rate or the same ratio all the way along. Can I do this? Everybody watch, please. Can I go back 1 and up 1? I can. Watch. Back 1 would be negative 1 for a rise and positive 1 for, negative 1 for a run and positive 1 for a rise. Okay, are these two the same thing? They are, because remember, I think we talked about this the other day. There are three ways to write a negative fraction. You can write the negative on top, out front, or on the bottom. So there's our linear equation. Do I put arrows on the end? I do. Y-intercept is 3. Slope is negative 3/4. I should switch these up and get some positives in here. Okay. Crosses at 3. Down 3 over 4. Down 3 over 4. Looks something like that. And it would be a good idea to put one on the other side. So let's go back 4 and up 3. Better make that look right. For some reason, my lines are more crooked when I draw on here than when I do it on the board. Okay. Any questions? We going too fast, or is this okay? Good quick review? Okay. So again, as we talked about, we can also talk about the slope as a ratio. Or in other words, it's the rate of change of y over the change in x. How much did y change versus how much did x change? And when we're dealing with a real world story problem, we call that a rate of change. We actually did one in the last section when we were talking about that piece of equipment depreciating. Its rate of change was negative $20,000 per year is what was happening there. Okay? So we've got a manufacturing problem here. A company is making bikes, and this is the equation that represents C, or in other words, it represents the cost. So we've got cost in dollars right here, and here we've got the number of units, or in other words, the number of bikes that they make. So you'll notice that the price, or excuse me, the cost to make more bikes continues to go up. Okay, so it costs more to make 150 bikes than it does to make 100 bikes, and so forth. Okay, and it says, well, let's see. Well, it really doesn't say anything. It doesn't really have any instructions. So let's look at this and think about this for just a second. This is a linear equation. What's this number right here? It's a slope. So on this one, the slope is, whoops, a little smaller. The slope is 25. And I heard somebody say it. No, was it you? It's 25 what? Ooh, 25 over 1. We want to think of it as a fraction. Okay? Now, this is a rate of change. So it would be really helpful, especially in a real-world situation, if we knew what the units were here. Okay? What's the unit on the vertical axis going up and down? Dollars. Okay? And what's the unit going right and left? Right. So if I were to draw this right here and do a little rise run, the units here would be bikes, and the unit here would be dollars. So if I have dollars here and bikes on the bottom, so this is dollars per bike. $25 for a bike. They can make a bike for 25 bucks. That's what that means. Now, if they make one bike, how much does it cost to make one bike? Now, don't answer out loud. I want you to look at the graph and I want you to think for just a second. How much does it cost to make one bike? Noah's got the answer. Anybody else? Hop? Noah, go ahead. $3,525, right? Okay, even though it's $25 per bike, that's how much it costs per bike. What does this represent right here? What do you mean by minimal cost? What would minimal cost if you were going to make bikes? All the supplies. You'd have to have somewhere to do it. Maybe you're making it in a garage or some, industrial area somewhere. You've got to rent some space. Probably need some tools and stuff like that. So you've got to invest some money. But once you invest that money, you can make all the bikes you want, it appears, for 25 bucks a bike. Okay? So if we figured out the average cost of making a bike, if we only made one bike, that bike costs $3,525 for one bike. How much would it cost if we made two bikes? That's one bike. Yeah. And if we did 2 bikes, this first bike would have been an average of $3,525 per bike. If you make just one more bike, what's the average cost per bike? Half of that. I think it's $1,775. So we dropped the price, per bike a lot. Does that make sense? So if I made 200 of these bikes, I get to spread this $3,500 over all of those bikes. Now, is there any way I'm going to recoup all my money selling one bike? Nope. Got to make a lot of them and sell a lot of them, because what that's going to do is it's going to decrease the average cost of each bike. Okay? All right. So the big picture here is that right there is a rate. It has units. The top is dollars, the bottom is bikes. So that 25 right there for the slope, its rate is $25 per bike. That's what it means. Okay, are there any questions there? Okay, we're going to cover one more idea on the next page, and then we'll be done. This is a good stopping space. Okay, when I learned these, this is how it made sense to me. I looked at that and I said, you know what? This is telling me what y can be. Y has to be 3, but x can be anything I want. So I'm going to say y is equal to 3, but x can be anything I want. So I can go as far that way and as far that way as I want. So if you only have one variable, it's telling you what one of the coordinates is, and the other coordinate can be anything you want. So by the same argument, this is telling me that x has to be -2, but y can be anything I want. So I can go as far up as I want, pretend that's straight up and down, okay, and as far down as I want. So if I get y equals a number, what type of line is that? Horizontal. Okay, please don't forget that. Y equals a number is a horizontal line. X equals a number then is a vertical line. Okay? So we could graph x equals -2, y equals -1, y equals 1.5. Anytime it's a y equals, it's going to be a horizontal line. Even x equals 7/4. 7/4 would be 1 3/4. What about these two guys right here? What about y equals 0? What is that? It's not the origin. It's the x-axis. Y equals 0 is an equation for the x-axis. So what's x equals 0? An equation for the y-axis. Okay? One more thing. Has anybody seen this before, point-slope form? Raise your hand if you've seen that. Hold it up high. Okay, about half of you. Okay, point-slope form is y minus y1, m, and x minus x1. The question we're going to start off next time is, even if you've seen it before, do you know where it comes from? It would be great if somebody could tell us that next time. All right, get done with 1.1. Get started with a couple of things on 1.2. If you see something on parallel or perpendicular lines, haven't got there yet. If you know how to do it and want to do it, that's just fine. Okay? Have a great weekend.